The structure of a soil and its consequent porosity has an enormous impact on its functionality and health. Among other things, a well-structured soil allows good movement of air and roots, holds water without waterlogging, and enhances microbial activity and nutrient availability.
To determine the soil physical structure, we use a system or a test known as the GrassVESS, VESS meaning Visual Examination of Soil Structure. It's a test that examines to a depth of about 20 centimetres, extracting a block of soil and looking at various soil parameters to determine whether the soil has been degraded by compaction. This soil test takes about 15 minutes to conduct, and we generally recommend that you do about 4 or 5 of them around the field to get a consistent result. So we start by digging out a pit of around 25 to 30 centimetres long, wide and deep. The important thing at all times is to make sure the spade does not touch the surface of one side of your pit, this surface in this case. Then we insert the spade at a straight angle and we are going to use this as our test block. We want to lift the soil block out intact and place it on top of our tray, and this is what we're going to be assessing. So we're going to lift it, trying not to let it fall apart, and you can see the soil is naturally starting to crack to show natural areas where there's a difference between the soil. We then lift the soil onto the tray. Now I like to let it drop a little bit just to get it to crack a little bit more under its own steam. We're going to go through a number of parameters to determine the quality of the soil, and to support that we're going to use the GrassVESS flowchart. So we start by breaking the test block apart, almost like opening up a book. So we distinguish between the root mass layer and the lower layer, and we're going to test each block separately. So following the flow chart, we start by looking at the porosity down through the profile, and this is very porous. Then we're going to look at the different aggregates. Now aggregates are how the soil naturally separates out into crumbs or blocks of different sizes. So the different sizes will tell us that ideally we want small sizes and we want our aggregates to be nice and round shape. We want to check how resistant they are to rupture. So we simply put pressure on them, and if they crumble easily with one hand, that's a very good indication of the structure. We also look within the aggregates, and we want to see if the roots and the porosity within the aggregates is good. Based on looking at these parameters, we follow the flow chart, and ultimately we determine the quality of the soil. Separately, we look at the root mass layer, and again we are looking for physical structures such as the density of the roots, the aggregate size, porosity. We're looking for to see if their aggregates are rounded or very angular. And we assign a root mass score of either 1, 2, or 3. 1 is optimal, 2 is moderate, and 3 is poor. For the lower portion, 1 or 2 is optimal, 3 is moderate, and 4 is poor.